Welcome to our first video of the rest of the year. We're going to be doing some online learning, and what I'm going to do is I'm going to take you through the lesson as I would do it during class time, but I'm going to do it a little bit quicker because you're going to have the ability to pause the video as you're taking notes. Now, as I put in the instructions, I recommend you read through the lesson first and see if you can figure things out, and then watch the video after that. Just confirm that you're getting everything correctly. Or if you feel better just watching the video, pausing it, and taking notes as you go, feel free to do that. I'm going to try and get this done in 10 minutes or less so it isn't too long of a video for you to watch. So parallel line and angle relationships. The first vocabulary term that I'm going to have you write down is that of a transversal. The transversal is defined as a line that cuts across or intersects two other lines. So if you look at my example that I put over on the left, you'll notice the line R is passing through lines P and Q. So line R is the transversal here. So I'd recommend you draw that image down as well. Now we're going to talk about three different types of angles with our transversals. The first one that I'm going to highlight is the corresponding angle. Corresponding angles are two angles that are in the same relative position of an intersection of a transversal and another line. So a quick example of that would be if you see this intersection here, you got four angles created, A, B, C, and D. Angle A is in the upper left-hand corner, and when you slide down to this same intersection but with Q, you'll notice angle E is in the same position in the upper left-hand corner. They are considered corresponding angles. Alternate interior angles are angles that are on opposite sides of the transversal and on the inside of the parallel lines. So let me change colors up here. Angle B is not on the inside of the parallel lines, it's on the outside. So angle B is not a part of alternate interior angles. These four angles, B, C, E, and F, are on the inside of the parallel lines. And the angles that are across from each other, angle D and angle F, are considered alternate interior angles, just as angle E and C would be considered alternate interior angles. Then the last type of angle we're going to talk about are same side interior angles. And the same side interior angles are on the same side of the transversal and on the inside of the parallel line. So once again, look at these four angles. D and E are on the same side of the transversal, so they would qualify as same side interior angles, as do C and F, okay? So once again, we take two lines. Most of the time, we're going to be working with parallel lines. P and Q are parallel lines. And so what we're going to notice in today's lesson is that there's a very special relationship between corresponding angles, between alternate interior angles, and between same side interior angles when we're dealing with a transversal that intersects two parallel lines. First of all, when you're looking at diagrams, pay attention to this. If the lines are parallel to each other, you're going to see this notation here telling you that they are parallel to each other. And if two lines are perpendicular to each other, I think you already note that little box implies that they're forming right angles. Okay, so I recommend you read through this problem, answer the questions down below to the best of your ability, with the video paused, and then come back and see if you're getting everything correctly. In these two images, go ahead and pause now. Okay, you're done pausing, you're coming back to me. These two image figures, one of them has parallel lines, as you can see with the arrows, and one of them does not have parallel lines. Both of them have a transversal. In this case, the transversal is line R, and in this case, it's line W. So what are the relationships between those angles that are formed with the transversals? So it says here, take a sheet of paper and trace these angles to the best of your ability. You could probably just look at them if you didn't choose to trace them, but maybe you traced them, that was great. So what do you observe here? And what I observed is that the angles A and C here have the same measure. So here's angle A and angle C. If you look at them, you could pull down the protractor. They look the same. They absolutely look the same. So angles A and C have the same measure. Then you take a look at angles B and D. What do you notice about them? They also appear to have the same measure. A and C are corresponding angles, and B and D are alternate interior. Notice how they look like they're about the same. These are acute angles, and A and C are obtuse angles. They look that they're the same. They are the same measure. That will always happen whenever you've got parallel lines being intersected by a transversal. Corresponding angles are congruent. The alternate interior angles will be congruent. Now trace E and G. Do they look like they're the same? No, they do not. Angle E looks like it is an obtuse angle, and angle G is acute. They cannot be the same measure. This is more than 90 degrees. That's less than 90 degrees. Take a look at angles F and H. They're also not the same. So if we were to summarize what's happening here, we could say that if the transversal intersects parallel lines, then the corresponding angles are going to be congruent to each other. If the two sets of corresponding angles are congruent, then you must know that the transversal is intersecting parallel lines. So you can go back and forth between those. If they give you parallel lines, you know that the corresponding angles will be congruent. If they don't tell you whether the lines are parallel or not, but you know the corresponding angles are congruent, then you know they must be parallel. All right, once again, please read through this section, pause the video, and when you're ready, after doing the work, then let's come back and see how well you're doing. So pause now. Okay, welcome back. Let's see what we've got here. It says we've got angles P and Q are always going to be our parallel lines, and line M will always be our transversal. So we need to identify, according to these directions here, what are the measures of these different angles based on what we see here. So angle A is given here as 107 degrees. So what I would like to do is I'm going to take all of the other angles that appear to be obtuse, and I'm going to highlight them in green. And then the ones that appear to be acute, I'm going to highlight in yellow. And that's going to help me answer some of these questions. Here, we've got an obtuse angle, so that matches up with this one, and this one, and this one. F is acute, so is H, so is J, so is this one. Taking a look at figure 3, all of the obtuse angles are 139 degrees. And all of our acute angles appear to be 41 degrees. Okay, so corresponding angles from a transversal intersecting parallel lines are always going to have the same measure. And if they give you one of those measures, you know all the others. So let's go through and see if we can fill these in. Angle B matches up with all of the acute angles, so this has to be 73 degrees. Angle D matches up with all the acute. Did I say, I hope I said obtuse angles for the yellow ones. The green ones are acute. So, or are they? I'm messing this up completely. No, I was right the first place. These are acute. These are obtuse. So angle D has the same measure as angle A because they're corresponding, so that must be 107 degrees. Angle F matches up with angle J, which is 28 degrees, which means this must be 28. And angle K matches up with angle G, which must be 152 degrees. Now, one thing I want you to be careful of, and I mentioned this in class last week, TPM likes to give you diagrams that are not completely accurate. So if you were to pull out a protractor and measure these, there's a good chance this does not measure 152 degrees, and there's a good chance this does not measure 28 degrees. Just go with the numbers that they've provided. Here on figure 3, angle T is 139, so angle R has to match that because their corresponding angles 139 degrees. And angle S and N are corresponding, so if this is 41 degrees, that must be 41 degrees. So let's see what the rest of these answers are as we scroll down. In figure 1, compare the measures of angle A and D. They are the same. They are both 107 degrees. Angle B and E are the same. They're both equal to 73 degrees. In figure 2, compare the measures of angles F and J. Well, they're both 28 degrees, and G and K are both 152 degrees. And then in figure 3, angles N and S are the 41-degree angles, and angles R and T are the 139-degree angles. So we can make conjectures here, and I think I've already stated it, but when you're dealing with corresponding lines, or I'm sorry, corresponding angles formed by a transversal intersecting parallel lines, those corresponding angles are always going to be congruent, no matter what. What do we have here? All right, so we've got another situation. I'm just going to skip over this. Hopefully, based on what we did on the previous page, you're going to understand what's going on. Now there's a conjecture for alternate interior angles. When you've got a transversal intersecting parallel lines, the alternate interior angles that are formed by that transversal are always going to have the same measure. So our conjecture is if parallel lines are cut by transversal, then alternate interior angles are also going to be congruent. And you can look at them. They look like they're the same. They are the same. All right, now use figures 1 through 3 on that previous set of problems to answer these questions. Examine the pairs of angles B and D, G and J, R and S. If you add those angle measures together, what do they add up to? I should have let you do that first before I gave you the answer, but I'll just give you the answer. It's 180 degrees. Write a conjecture about the two angles on the same side of a transversal and are between parallel lines. These are called same side interior angles. So what do the same side interior angles always add up to? They're always going to add up to 180 degrees. Now, why is that? Let's go back and look at some examples here. These two angles right here are forming a straight line. So they are supplementary angles. We learned that in 6th and 7th grade. Supplementary angles are two angles put together that add up to 180 degrees. So if angle 1 and this angle are supplementary, then angle 2 and that angle also have to be supplementary since angle 1 is equal to angle 2. Go ahead and look through the examples, and I'm sure you will see that that is the case in all of those situations. So with that the case, we now know something about the relationships of these angles. So we're going to be able to answer these questions. So please draw this diagram down, pause the video, write down the questions, and let's work through the questions. Try and figure out the answer. I'll be back in a second. Go ahead and pause. Okay. In these situations, I've highlighted all of the congruent angles. All of the acute ones are in yellow, all the obtuse are in green. The measure of angle 2 and angle 5, they are forming a straight line. Those are supplementary angles, which means their sum has got to be 180 degrees. So I can figure out the measure of angle 5 by taking the measure of angle 2, which is 67 degrees, and subtracting it from 180. That makes the measure of angle 5 have to equal 113 degrees. And that's what this M means. When you're just talking about the angle 5, you would just call it angle 5. Use a little like kind of a slanted L shape here. But when you want to find the actual number of degrees, we'll call that the measure of angle 5. To solve for the measure of angle 4, we know it's 4x plus 23, and the measure of angle 6 is 3x plus 17. Once we solve for x, because we know that this plus that equals 180, look through my work here. I'm going to add these two angles together. They add up to 7x plus 40, and the combined total is 180 degrees. So when I solve for x by subtracting 40 from each side and then dividing by 7, I see that x has to be equal to 20. Now, if I want to find out what the actual measure is of these angles, I will plug that into this expression and then simplify. So to answer question D, if the measure of angle 4 is 4x plus 23 and the measure of angle 6 is 3x plus 17, then angle 4 must be 4 times 20 plus 23, which is 103 degrees. Good luck with these problems. Good luck with the homework. I will post a video that goes through and explains all of these problems on the homework. Thank you.